Hello everyone. This is a lengthy question. I would like you to go through the question before seeing the solution. I would read out for you. So the question given is a small block of mass m is kept on a bigger block of mass capital M, which is attached to a vertical spring or spring constant K as shown in the figure. The spring system oscillates vertically. Three subparts are given in this question. The first one is find the resultant force acting on the small block when it is displaced through a distance x above the equilibrium position. So first let us deal with this first part, then we will see about the second part. Now both the blocks are in SH. Let us assume this is the mean position, and now blocks are a distance x above the mean position. Here if you consider the omega value, generally omega is root of k by m. Here m will be the total mass of the system as both the blocks are oscillating capital M plus small m. This is omega value. Now both the blocks are oscillating, so both the blocks will be having the same acceleration, which is, if it is at a distance x from the mean position, then the acceleration will be given as omega square x, which is the basic property of SHM, and that acceleration will be always acting towards the mean position. So here acceleration of the small m block will be equal to the acceleration of the capital M block, which will be is equals to omega square into x. Now if you want the force acting on small m will be is equals to mass of the block into acceleration of the block. This will be is equals to m omega square into x. Here you can see omega square will be is equals to k divided by capital M plus small m. Just substitute that value here. So this will be is equals to mk into x divided by capital M plus small m. This will be towards the mean position, which implies this is going to act in downward direction. This will be the solution for the first part. Now let us see the second part here. Second part, we have to find out the normal force acting on the smaller block at this position. When is this force smallest in the magnitude? Right. Now let us see only the free body diagram of the smaller block M. You can see there is a contact force acting between the blocks, which will be in upward direction, that I am representing it here, capital M, and weight of the block will be acting in downward direction, mg. Acceleration of omega square x will be acting in downward direction. Now if I write the force equation, you will be getting mg minus n is equals to m omega square into x, which implies here n will be is equals to mg minus m omega square x. So this is the expression for n. Here the only thing which can be varied is x. So more the value of x, less will be the value of n, mg minus m omega square x. X will be highest when it is at the upper extreme position or lower extreme position. So n is going to be lowest when x is equals to amplitude, or you can say upper extreme position, when particle is at upper extreme position. Next, if you see part C, what can be the maximum amplitude with which the two blocks can oscillate together? Right. Here we have to find out what is the maximum amplitude which they can oscillate without separation. When they separate, the normal reaction is going to be 0, and the probability of normal reaction being 0 will be at the upper extreme position when x is equals to a. So maximum we can go up to a condition where normal reaction can be 0 at upper extreme position, which implies mg minus m omega square into a max, maximum amplitude without separation, will be equal to 0. So from here you will be getting a max will be is equals to g by omega square. Omega square value, we know that it is g by capital M plus small m. Here that capital M plus small m will go to the numerator. So this will be the a max with which it can oscillate without separation. That will be the total solution for this question. Thank you.